All right, we are going to review the Pythagorean theorem. Again, we're gonna spend 2 days on this, and this should be really easy. I'm gonna give you 2 grades in Verge for test grades, and the test grades are what are really pulling your average up. All right, remember the Pythagorean theorem is only used on a right triangle, and it's to prove that it's a right triangle, and it's a squared plus b squared equals c squared. Your a and b are your legs. Remember, they make that letter L for legs, and C is your hypotenuse. Now, I have attached a PowerPoint as a review in Verge and on my website if you want to remember more about it. But what I'm going to do right now is I'm going to do 2 examples of finding the hypotenuse, 2 examples of finding the leg, and 2 examples where I give you 3 sides if they are actually a right triangle. All right, so for the first one, let's look at this. Remember, for these, you are going to need a calculator. Okay. So first thing we need to do until you get comfortable, and you might just get comfortable after one problem, is go ahead and label it. This is B, this is A, and this is C. Now, again, does it matter which order, which one's A and which one's B? No, it doesn't matter. Okay, but it does matter C. Remember, C is the good longest, and it's always opposite the corner, the right angle box. All right, so once we get this all labeled, we are going to plug it into the Pythagorean theorem and see what we're missing. We have A is 3, so we're going to have 3 squared, plus B is 3, we have 3 squared, and since we don't know C is C squared. So 3 squared is 9, plus 3 squared is 9, equals C squared. You add 9 plus 9, and that's 18, equals C squared. And then what you have to do is, I want to know what number squared equals 18. Well, what's the opposite of squaring? Square root. So we take the square root of 18, and that's going to equal C. And on your calculator, you take second, oh, I just turned it off. Okay, so we take, remember now some of y'all square roots are written on the calculator, some of them have a button. This one's written on the calculator on the x squared. So I'm going to hit the second function, x squared. I'm going to hit 18, and I'm going to hit enter. And let's round these to the nearest tenth. So 4.24 is going to be 4.2. Okay, so that's the first one. Next one, again, another one we're trying to find C. C is the hypotenuse. So again, we are using a squared plus b squared equals c squared. Label them. This is A, this is B, and that's C. A is 2, so you're plugging it in. 2 squared plus b squared equals c squared. 2 squared is 4. 5 squared is 25 equals c squared. You add 25 plus 4, you get 29 equals c squared. To get c, you need to take the square root of 29 again. Okay, so second square 29, and we're going to round to this nearest tenth. I get 5.38. Okay, so this is 5.38. What does the 8 tell the 3 to do? Go up to a 4. Okay, so C is going to be 5.4. So that's your hypotenuse. Okay, all right, now let's look at 2 where you have to find a leg. For example, this one had labeled that is B, this is A, and this is C. So again, we are going to plug what we have into the Pythagorean theorem. So A squared is 6 squared, plus B squared we don't know, but it does equal 10 squared. Now remember, when you're finding the leg, this is the one that you have to subtract. So 6 squared is 36, plus B squared equals 100. Now what you need to do is you need to isolate the b squared. So we have to undo adding 36. So we're going to subtract 36. We're going to get b squared equals 64. And then the last thing we're going to do, we don't want b squared. We want to know what number squared equals 64. And the square root of 64 is 8. Okay, so b is 8. And again, if you want to check it, just plug it in. We have a squared plus b squared equals c squared. Is 36 plus 64 equal to 100? Yes, so you did it right. All right, let's look at another one. Another one where we're finding B. So this is A, this is C. Again, we are using a squared plus b squared equals c squared. So we have 4 squared plus, we don't know what b is, b squared equals 11 squared. 4 squared is 4 times 4, 16, plus b squared. 11 squared is 121. Then what we do, we got to isolate the b squared. So this is a positive 16, so we're going to undo it by subtracting 16 from each side. Don't need a calculator to do this. Okay, it becomes 1, it's 11. 5, 0, so that's 105. Okay, then I don't want to know what number squared equals 105, so the opposite of squaring is the square root. So in our calculator, we're going to take the square root of 105, and I'm going to get 10.24, which is going to be 10.2. Okay? All right, now what if I give you what looks like a right triangle with just 3 measurements? I want to know, is it in fact a right triangle? Well, what you need to do is label the sides again. So this is A, this is B, this is C. And what we're going to do is we're going to plug it into the Pythagorean theorem and see if the math works out. So we have 9 squared plus 12 squared equals 15 squared. 9 squared is 81. 12 squared is 144. 15 squared is 225. Again, you don't need a calculator. You can just go over here and do 144 plus 81, 5, 2, whoops, yep. 225 equals 225. So yes, this is a right triangle. Okay. All right, let's look at another one. Again, let's label leg, leg, hypotenuse. Okay. And we're going to plug it into a squared plus b squared equals c squared. So we have 7 squared plus 4 squared equals 10 squared. 7 squared is 49, 4 squared is 16, and 10 squared is 100. Well, I can look at that and say that 49 plus 16 is not equal to 100. So this is, no, it's not a right triangle. Okay. All right, now your assignment is inverged. You've got 10 questions. That will be a test grade. So good luck. And again, there is a PowerPoint if you need the extra help.